Okay. So we're just looking this over from last night. This is your warm-up, dashboard history, period 5, radical graphs. So when we looked here, you guys can see if you did it right, they look like the others. And so there should be no values here on this negative side of the axis, which we're kind of seeing that, right? These should not be here. We have this function and it begins at 0, 0, and then it goes this direction and it would keep going. And because we're taking the square root. And so when we look at the domain values that work really well, we want to select the values that we can take the square root of. Excellent job not selecting -2 and 0. And then I'm going to anonymize. We're going to see 0. Yeah, we know the square root of 0. What's the square root of 0? It's 0. We know the square root of 1. What's the square root of 1? 1. But do you guys know the square root of 2? No. Do you know the square root of 3? No. Do you know the square root of 4? What's the square root of 4? 2. And so we should select 4. And then do we know the square root of 5? 6, 7, 8, 9. Yeah, what's the square root of 9? 3. So I'm seeing that, yeah, more students selected 9 than 8, which is good. We just wanted to select the values that do work or that are on those green dots. So that means that going forward in our notes, we're going to be using 0, 1, 4, and 9 as our X values that we're going to plug in every time. Those are the X values that work. When we look at our sliders, you were just meant to see how they affected the graph overall, just for fun. And then sketching the function, let's check the overlay here. It looks to me like most students did start at 3, -1, which is really nice. And then most sketched it facing down. That's as much as I wanted for this first try. Excellent job so far. Really good on just that warm up. And then looking at the next one, did we sketch this one? Looking at the overlay here. This one should have been really accurate. I'm seeing very good. Just a few students not knowing which way to put the arrow. This one looks great, and that's because we use that HK table. These are the X values, these are the Y values from the parent, and then we use the transformation table. Finally, just a sketch for fun. Went a little crazy here. And then let's look at the correctness here. Okay, for those students that did their matching of the domain and range, most students did it. You can see some students did not finish this. So when I'm looking at this from my student perspective, I click on the graph and I see that the X starts at, that's an X value of -2, and the Y value is looking to be 4 here. So the domain would be -2, the range starts at 4, and we see that both of those go towards infinity. On this next one, it looks to start at 0, 0. Yes, 0, 0, and so that's going to be the domain and range that have 0, 0. And then this one over here, this spot here is 3, 5. And I see that it is facing down, and that's why the range has -infinity to 5. So what we're seeing about this is that the domain and range only have one infinity. The domain always has positive infinity, and the range can have negative infinity. That was the big idea I wanted you guys to see. Let's take a look at our notes. So we'll start here with our parent function. So those of you who haven't gotten this out, let's take these 6.2 notes out. And we want to take a look at 6.2, but I also want you to turn the page over to 6.3 to compare what's coming next. And where did my fun ball go? Oh, here it is. Guys, I got a new ball. It's like a foam squishy ball. It just showed up in my room. So, oh, if it hits you in the face, no injury. Okay, and this will be our like talking piece. We'll have so much fun. Oh my gosh. Yes, Caitlin, you get to start it out. Okay, so students, we're looking at 6.2. This is called the square root function. Okay, there's nothing in the pocket. Caitlin, what is section 6.3? Cube root. And what I noticed about cube root is that it looks almost the exact same as square root. How are you, a student, going to be able to tell them apart? Take a minute and tell your neighbor how you're going to tell square root from cube root. Oh, I heard that beautiful term, the little pocket. That's right. The cube root has got a little pocket number, right? In the pocket, we've got the 3. We're going to have to really pay attention to, is it in the pocket or is it an A value? So A value is going to be outside. The pocket number is meant to be smaller and kind of like up a little bit. So we're going to start with square root function. This is related to the warm up that we did. And we already talked about the X values that are really good for this. And Caitlin, you get to toss it around. Who is the next person? Oh, Allison, what were those X values that we selected?
-2.
Ooh, the ones that worked. -2 does not have a square root.
Oh, 0,
Good.
2, 4, 9.
Very close. 4 and 9 are correct. Between 0 and 4, it has a square root. Ella? 1 it is. Excellent, you guys. These are going to be the numbers that we use every time. I'm trying to make my graph a little bit bigger so you guys can see it better. These are like the notes, but it's not working. Delete. What if I go like this? Nope. That's clearly not what I want to do. Let's try one more time. All right, whatever. We'll just have to use the smaller graph. Okay, cool. Passing it on. And Sophia, when I take the square root of these 4 numbers, what do I get? So what's the square root of 0? Yeah. What about the square root of 1? Did you say it? 1. What about the square root of 4? And the square root of 9? Beautiful. These are the specific parent values that we're going to use. And your guys' graphs from the last time were really good. Those are the best graphs I've seen. So we're going to stay with the AY table. And so we're going to start by plotting the parent. You remember we start at the origin 0, 0. Then you can see that these are the values we're passing through 1, 1. We go over 4 and then up to 4, 2, 1, 2, 3, 4, and 2. And then we go over 9 and we go up 3. And then we could keep going this way, right? We could plug in, what's the next number that we could plug in that would make sense that we take the square root of? Bigger than 9, we can take the square root of it. 16, and then 25 and 36. And so the numbers are getting bigger and bigger and bigger. So we're going this way and we need to place an arrow at the end just to indicate that it will continue that direction, but it starts at the origin kind of out of nowhere and is only going one direction. Okay, is One Direction still a cool band that we know of? Is it? Too bad, too bad. Okay, so we've got our HK, it's 0, 0, which means my x-intercept and my y-intercept are also both. Passing it on, Sophia. 0, 0, that's right, that one was lame. Okay, and then our domain. So when we're looking for domain, that means that we're reading along the x-axis, but overall just looking at the graph starting here and going this direction for the domain. And following that pattern, what is the first x value that you encounter? Point to it and tell your neighbor. Okay, great. And Serenity, passing it to somebody. Okay, and Tony, what is that value that we encountered first? 0 is correct. And because we are at 0, you guys pointed to it on the graph, we're gonna hard bracket the 0. And where is the arrow pointing toward? Infinity, and that's positive infinity, and this looks great. This is how our domain works for the parent. Let's write in the pattern for all of them. Switching back to pink. This is always going to be h to infinity. So just like we saw h in our domain for the rational functions, this one is also going to have h, and it's always going to be hard bracket h to infinity. We're not going to have a negative x, so we're never going to have x going towards negative infinity in this class. All right, cool. Passing it on, we're going to do the same thing for the range, except the range goes like this. So we start at the bottom. This is going to be for the range. And we're going to go along the y-axis until we meet our first y value, and then we're going to see if it's going up or if we've already met our y value and then we meet our maximum. And so doing that, Enrique, what is our first y value that we encounter? Starting from the bottom and going up. 0 it is. And is 0 an ordered pair on the graph that is plotted? Yes, and that means we're going to use hard brackets. And it starts at 0, and where does it go towards? Where's the arrow pointing toward? Infinity. Excellent. Now the range is going to change based on A. So positive A is associated with positive infinity. Does that make sense to you guys? Okay, so this is going to be for my positive A. Let's do positive A over here. And let's do negative A over here. So for positive A, our range. Going forward, what letter for the range are we going to use? Not H, but Jaden, or yes, not H, the Y value? K it is. So this will always be K to infinity as the standard. And so for the positive A, it's going to be K to infinity. However, for a negative A value, we're going to go to negative infinity. Negative infinity is at the bottom of the y-axis. And so that's going to come first. It's the first thing that we meet. So for a negative A, the range is going to be negative infinity until K. All right, now we're going to look at the increasing and decreasing interval. I just put the wrong thing there. For the increasing or the decreasing interval, it's only going to be one or the other. We're going to use the domains. Take a moment and trace this function the way that you trace the domain with your finger to determine if it's increasing or if it's decreasing. And passing it on, Jaden, to the next person. All right, Avery. Avery, you didn't grab it. You're right there. Okay. All right, Nick, it's your turn. Is this function increasing or decreasing? It's increasing. And so what do we say for the increasing interval? Indeed, 0 to infinity. I've written it in this lime green to remind you that we use the domain for this. Since it's only increasing, do you guys know what we put for decreasing? NA is fine, NA or the empty set. Great. The idea of one-to-one is, does it pass both the vertical and the horizontal line test? Look to see if it will do that or not. Passing it on. Nate. Okay, does it apparently pass the vertical and the horizontal line test? Yes or no? Yes. Well, good. The answer is yes, and the answer is always yes. Cool. And then the minimum and maximum, I need to switch to lavender. Those are related to the range. So the minimum is the number on the left of the range. The maximum is the number on the right of the range. However, infinity is not a number. So if it's infinity or negative infinity, we use NA because they're talking about the minimum value or the maximum value, and we never reach infinity. So it's like you never get to the maximum, or if you're swimming down to the depths of whatever, you never get to the very bottom. And so for infinity, we say NA. So in this case, the minimum is what value, Theo? Oh, good. And what about the maximum, Theo? NA, excellent. So when we have a positive A, we're going to have a minimum of K and a max of NA. But then we're going to have a minimum and a maximum reversed for a negative A. So for a negative A, the minimum is going to be non-existent. We go down to negative infinity and we just keep on going. But the maximum value is K. I just noticed I forgot a parenthesis here. I don't know why. It's supposed to be there. I just didn't write it down. So that's our parent square root function. This function is what we're going to compare to when we describe our transformations. So does it get stretched and made taller, or does it get even flatter and get compressed? Do we reflect it over the x-axis? Those are all the things that A can do. Then we'll look at H, moving it left and right, and we'll look at K, moving it up and down. Have you gotten all this written down so far? Okay, I'm gonna erase it all. And we're looking at our transformation refresher. So I've typed these in here and then highlighted it. This is the same as last time. If A is negative, the words that we use are reflect over the x-axis. If A is a fraction smaller than 1, we say compress by a factor of A. If A is a number larger than 1, we don't care if it's negative. If it's negative, we say reflect. But if it's -2, we say reflect and stretch. So if it's a larger than 1, we'll say stretch by a factor of, and then whatever the A value is. And then just remember for H, we have to switch the sign from how it appears. And then once we have that, we know that left is negative and to the right is positive. And we say shift left or shift right, H units. And then for K, it will be shift up or shift down, K units. And I'm hoping this is a review. Allie, did you need another packet? Okay, you're not gonna write anything down? I would love it if you just grabbed another one and get all this. I do, yeah. I don't want you to not have the notes since you're here. Okay, and I see some of you guys are still writing this down, so I'm gonna let you guys finish. Do I need to zoom make it bigger? I can't make it any bigger. All right, once you've got this, we're gonna turn the page. And once I see that you've turned the page, I'll be happy. It's Ella. Okay, are we ready to turn the page? I'm hearing pages turn. Okay, cool. Oh man, I already did the work. Oh dang. Okay, well, how can I hide it? I can't. What? Oh no. Oh no. Okay. All right, who's got it? All right, Milana, what's our A value?
The A value is 3.
Great. And the H and the K?
The H is -6 and
Right on. So just listing the HK as -6, -4, we're gonna do what we did previously because I found that to be really good. You guys did a really good job graphing our most complex function when we used just the AY table. So we're going to plot HK and sketch the new, axes. So I'm finding -6, -4 on the graph. That's 1, 2, 3. Oh man, it's so hard to see. And then 1, 2, 3, 4. And then I'm going to sketch my invisible new x and new y axis. They're not asymptotes on this function. This function does not get asymptotes. It doesn't have that weird end behavior going on. So I'm just sketching this to help me orient. Okay, and now I have a new pretend x and I have a new pretend y axis. And what I'm going to do is I'm going to make my AY table. So that's the 1, 2, 3 column chart. I've got x here. This is the y equals the square root of x. And then this is the AY column. And in this case, the A value is 3. So I'm just going to write above it as 3 times y. We want all that information here so that we remember how we generated the table. And if you have to look back, okay, look back. But if you can kind of challenge yourself, that would be really cool too. Let's try to remember what the x values that work that go into square root would be. So Milana, we're passing this along. And Petra, what are the x values that we're going to use? There are just 4. 0, 1, 4, and 9 is correct. Excellent. And passing it on. And Anna, what about taking the square root of those 4 values? What are those y values we get? Excellent. And now we're going to multiply these y values by 3 to get our AY values. And passing it on to Avery, what are those values? Yes, and I just wrote 1. I don't know why I didn't listen to you. 0, 3, 6, and 9. Excellent. What we do now is we do that gentle slash, and we're going to plot from HK. And so I begin at 0, 0, and yes, I am still here at 0, 0, and that is an ordered pair on this function. Then I'm going to go over 1 unit to the right and up 3 units from my HK. So over 1 and up 1, 2, 3. After that, I'm going to go over 4 and up 6, but I need to begin back at my HK. So starting back here, I'm going to count over 1, 2, 3, 4, and then up 6. So 2, 4, 6. Well, geez. And then finally, I'm going to go over 9 and up 9. So this is 6 right here, 7, 8, 9. This is 4, 5, 6, 7, 8, 9. And we want to remember on this last one to draw the arrow. So in the last y value, we're going to draw the arrow. So this one goes like this, and it's facing up. I'm just going to make my line a little bit thicker for this so we can see it really well. And that looks great. Jaden. We can extend it, but I don't have any more specific values or ordered pairs. So drawing the arrow. Yes, yes. Okay, cool. So now we're going to do the stuff that we've already done. We're going to skip the x and y intercept because I can see them, but I can't tell exactly what they are, right? Here's that. I don't know exactly what this is. And here's that. I can't see the exact values because I didn't land on it. And so let's look at the domain. So again, we read domain left to right. Who's got the ball? Passing it on. All right, Nick G, what's our domain this time? Ooh, here's 0, and I believe we started before 0. So we've got the bracket, and remember it changes based on our h value. So yep, -6 to infinity. Bien, passing it on. Ella, what about our range? -4 to infinity is correct. We see that we begin at -4. It's not pointing down to negative infinity. Great. So now we need to determine the increasing or decreasing interval. One of those will be NA. So what we do is we trace the function with our finger, right? Nick, increasing or decreasing? I agree. When I traced it, my finger was going up overall. So this is increasing, meaning decreasing is NA. And what do we say for the increasing interval? We don't say yes. We're going to say the specific interval. Indeed, we use the domain. Very nice. So again, we use the domain twice. So the fact that it was back to you is appropriate. For a one-to-one, passing it on. And Jacob, what do we say? Great. And then Jacob, let's also do the minimum and maximum. So the minimum Y value is what value, Jacob? The smallest Y value when you read the range, or it's on the left of the range. Correct. What is the largest Y value? It would be infinity, but we don't write infinity because that's not a value that we can reach. So what do we say instead? We say NA. There's no such thing as the maximum. It goes on for infinity. I know that's a little bit tricky. Okay, now we've got to do the work to find the X and Y intercept. So let's first describe the transformation, since that's going to be, there's no math involved. So passing it on to whomever you select. Honor, it's coming to you. You knew it was coming for you. All right, Honor. The A value is equal to 3. What does that do to our function? And we say stretch by a factor of 3. Excellent. The H value is -6. What does that do to our function? Left 6 units. Excellent. The K value is equal to -4. What does that do to our function? Down 4 units. Excellent. We did it. Questions on the transformations? Whoops.
Wouldn't X just be -6 and Y be -4?
No. Those are the HK. That's where we begin our function. The intercepts are associated with 0. So we're going to do the work for those right now. They take up quite a bit of work. So if there are no questions on what we have, I'm going to erase everything. Are we ready to go? Okay, I see a no. So I don't want this box here. I want it to go away. So I click undo. Okay. Okay, I'm going to clear it out now. We're going to do the work for the x-intercept. The work for the x-intercept starts with us plugging in 0 for y, and it's 3 times rad x plus 6 minus 4. The first 2 steps are going to isolate the radical. Honor passing it on to somebody. Gil, what's our first step? Okay, nope. We're trying to find the x-intercept. So we're trying to isolate the radical.
Oh, so square both sides.
Okay, so we actually need to isolate the radical before we square. That is one of the steps. Add 4. Yes. And then we're going to divide by 3. That's correct. Excellent. So we have 4/3 is equal to the square root of x plus 6. Excellent. Passing it on. We've got 2.5 more steps to solve for x. Ben, it's coming to you. Be ready to catch it. It is. Oh, it is. We're about to see it. Indeed. Okay, Ben, how do we get rid of the radical? We square it. We square this. And just as a reminder, that just means we're going to square both the top and the bottom. So what is that fraction going to become, Ben? We're going to square the top and the bottom. So it's going to be what over what? And now the x plus 6 is free. And it's just x plus 6, no longer in the radical. We undid the square root operation. And Ben, what's our next step after this? Yeah, 2 steps. Subtract 6. Great. I want to subtract 6, but I see that it's divided by 9, so I need a common denominator. So I'm going to really think of this as multiplying by 9 over 9 to get that denominator of 9. Ben, passing it on. We've really got kind of 2 more steps. Who's got it? Enrique. All right. He's ready to catch it. Thank you. So Enrique, I'm multiplying this 6 and the 9, and what do I get? 54. It's negative 54. And then it was positive 16 over 9. So I'm exaggerating that positive by putting the plus sign. Can you guys see that? I wrote really big up here, and then I'm starting to get a little bit smaller. Okay, so we've got negative 54 over 9 plus 16 over 9. So now we just need to add those 2 numbers together. Technically, we are subtracting, and we're going to get a negative. How many over 9? Enrique? 38. And I love it. That's correct. So our x-intercept is negative 38 over 9, unchanged. We'll leave it as that improper fraction. Grace. As long as you have it as negative 4.2, because it repeats. So you don't want to round it when it repeats. Cool. So our y-intercept is so much easier. So don't worry too much. Our y-intercept, we're going to plug in 0 for x. And let's do a little bit of mental math. Enrique, passing that on. Tony, what is 0 plus 6? Yes. And so do we know the square root of 6? I don't know it either. And so I'm going to leave it as exact. So the y-intercept is 0, comma, and I don't do any math at all. I did plug in 0, and I did that tiny bit of mental math. It's still 3. It's still rad 6, and it's still minus 4. That's my answer. I'm going to leave it in exact form. I don't know why my comma looks so funky. Let me make sure that that doesn't look like a negative sign for you guys. That is just 3 rad 6 minus 4. That is the y-intercept. All right, cool. We have one more to do. Let's take a look at it. This one is number 3. And do I have to erase here? Oh, man. So you guys see, I already found the A, H, and K. So you guys can just copy that down. Our A is -1 when we don't see it. There's a 1 there. There's clearly that negative sign. We see the H and K. And great. Tony, passing it on. All right, Kyle. So what do we want to do next? All right, let's graph the HK. I'm finding 4 for X, 9 for Y. This keeps happening. And from this ordered pair, we want to sketch our imaginary X and Y axes. So just a dashed vertical and dashed horizontal line so that we can orient our ordered pairs from here. Excellent, passing it on. What are we going to do after this? We want to graph it, so what do we have to do? We need to make the table. The table has 3 columns. X, Y, oh my, why is it highlighting? It is, it's because I'm using the word. And then what is that third column, Nate? So what does it say? -1 times. Excellent. All right, Theo, what are the x values that we use for the square root function? 0, 1, 4, 9. Excellent. And what are the y values that we use? 0, 1, 2, 3. Excellent. Passing it on. Nick Jones, what's our new y values going to be?
0.
Excellent. Gentle slash, let's plot all of those values, but first start at our new HK. So 0, 0, yep, I'm there. 1 for x, -1 for y, great. 4 for x, -2 for y. 9 for x, no, I'm just off the graph. So I'm just gonna draw my arrow pointing this way, but I'm also noting that I'm sort of pointing it down. It's going down. The y values are getting smaller. This is so hard because I normally use a ruler that has curves to draw curves. Right? Who is an APA and does pattern making? Costume design? Nobody? Too bad. Okay, whose graph looks just like mine? Fabulous. Okay, Nick, passing it on. All right, Milana, what's our domain this time?
The domain is.
Yes?
So would it be 4 to infinity?
Yes, it would. Passing it on. Ben, cool. What about our range? Ooh. Well, I noticed that this arrow is sort of pointing down. -infinity until where? 9. This is how we do the range for a -a value. And so this is our first time doing the -a value range. We start at -infinity, but then it stops at 9 and there are no values above 9. All right, increasing or decreasing, take a moment and trace it. And when you pass it on, that person will tell me both the increasing and the decreasing interval. Who's got it now? Avery, what is the increasing interval? It is. When I trace this function, it's definitely decreasing. So what do I put for the decreasing interval?
4,
That's right. I do 4, infinity. I use the domain. The domain. Great. For 1 to 1, we say yes. For the minimum and maximum, that's going to be our next for the next player. Who's got the minimum and maximum? Bella, the minimum. Remember, it's going to be on the left of the range and then on the right of the range. Correct, because it would have otherwise been -infinity. And the maximum is? Indeed. So the minimum and maximum are referring to y values. Right on. Now we're ready to do our transformations, listing those out and passing it on to our next player to do the transformations. Yes, you do. Use a word. Use a name. Gilberto. Oh, a little bit soon. All right, Gilberto, our A value is -1. And so what do we say about that? Compress only has to do with a fraction smaller than 1. 1 is equal to 1. And so we're not going to use the word compress. What is the word we use for negative? Nope. Okay, and the math word that we use for flip over is reflect. So we say reflect over the x-axis. Excellent. The h value is 4. What do we say for that? And finally, what do we say for the k value? Awesome. Students, how are we feeling about describing our transformations? Good, awesome. So we just have two pieces that we need to fill in, the X and Y intercept. Take a moment and look at this function and tell me which intercept will not exist. Tell your neighbor which intercept will not exist. Okay, hopefully you guys said that this is where the y-axis is. And the x value here is x is equal to 0. But look at the domain. Is 0 between 4 and infinity? Is 0 between 4 and positive infinity? No. So it's not going to have a y-intercept. The y-axis will not be touched. So the y-intercept is empty set, or we can also say NA. Who else saw that the y-intercept would not exist? Good, okay, good. Good, now the x-intercept, we see that this is angled down, and so a long time from now, it will cross the x-axis. Let's do the work to find out when that will happen. Nope, okay, see, I used my word. Okay. Cool. I need this space here. The function is, we've got 0 is equal to negative, and then it was x minus 4 plus 9. And let's take a moment and solve for x. So who's got it? Was it Honor? What's our first two steps? All right, do the whole thing. All right, we're going to divide by -1. That's just going to change this to 9 is equal to the square root of x minus 4. Now I have 81 is equal to x minus 4. And finally, and x is equal to 85. And we write that as 85, 0. Awesome. I do want to show the work for the y-intercept. And let's just take a look at what that would be now. So before I move on, do you guys follow the steps for the x-intercept? We went through that pretty quickly. Are we good? So we isolate the radical, making sure to divide by whatever a is, if there's an a value. Once the radical is completely isolated, we square it, and then we just add or subtract. So great. So here's the work for the y-intercept. It's y equals negative rad 0 minus 4 plus 9. So if you weren't super observant, you would look at this and you would keep going. And Ellie, what would we do next to simplify this? So I would actually simplify inside here. And what would I get as my answer? Just adding these together. -4. And in the first semester, we learned the square root of -4. Does anybody recall what the answer to this is? 2i. Who knew it? Nice. So I've got -2i, an imaginary answer for this. And then I have the plus 9. And this is correct math. And this is totally great, but we do not graph imaginary numbers on our graph, right? This is not an imaginary number graph, it's a real number graph. And that's why there's no y-intercept. So super cool. You guys can grab your worksheet. It's over there by me. And you guys can get started. Thank you.